Okay, so now we're getting started with the keel, and yeah, maybe first we're gonna explain what
are we getting started?
Yeah, and as we shown in a previous video, we have this. I don't know. We call it a swing keel. I don't know what the best term for it is, and it like folds up. I don't know. A few weeks ago, I don't remember when it was. We noticed some cracks in the. It's a hydraulic unit that runs this swing function. Yeah, in some of the hoses here, there are some cracks.
We kind of put the whole keel thing as a huge unknown, I would say, all the time. And it's still a huge unknown, even though we've been able to run it. I mean, that doesn't make it reliable, and we want something reliable. So right now we're basically in a state where, yeah, we're not really sure exactly what we're gonna do with the keel situation. I mean, we are basically all doors open. Independently of what we're gonna do, we at least need to, if we were gonna keep this keel, we need to go through it basically.
Yeah.
And I mean, one obvious thing is obviously to change the hydraulics down here. One problem is that the feed lines go through, that feeds all the hydraulic cylinders. It goes in there. It's one solid hose all the way here through the keel, and it enters by the keel bolts in the hull. And the problem is that hose is very difficult to change.
Because you have to remove the entire keel in order to do that, as far as we have understood it.
Yeah, maybe you can in some way kind of drill your way all the way through here and kind of drill the old hose out and put in a new one, but that's difficult to say at least. And anyhow, I mean, if we're gonna restore this one and run it, we still want to really go through it, which means kind of pretty much taking everything apart. And we're not gonna do that today, but we're gonna start to just try to loosen some bolts here, just to get a feeling of what we're working with. The lower part, the wings, each side weighs around 1,500 kilos, so they're quite heavy, and they're clamped in this like a compression here between these plates here, and then they hang on like an axle or a tap here. So first step would be then to we're gonna loosen one by one here and feel how they feel, and then we're gonna, at next point when we're actually gonna take it off, then we will probably swing it up to some angle. Then we'll have a forklift coming in underneath, supporting it, and then you lose these ones, all of them, and then you kind of pull the part out, in theory at least. And then you do the same thing on the other side, and then from there you can loosen these all bolts, and on the other side, and that's like the, I don't know what you call it, we call it a bearing or whatever, but the holders for the whole mechanics basically. Then you take them apart, then we know a little bit more, hopefully. Let's get going.
Just try the first one. It was
almost too easy. Probably all do it. Yeah, this is really tight with the paint. This was almost ridiculously easy. I wonder if the nut was spinning inside as well, but I mean, highly doubt that this will be a problem.
We try to loosen some of the bolts, and next step will be to run the keel a little bit, so we can try some of the nuts on the inside.
Yeah, so let's try to run it then.
Do you want to go down?
I should go down, yeah.
Here, you can take this.
Stop! Stop!
We added some support in case something should happen.
Yeah, if we burst a hydraulic hose or whatever, then hopefully this will hold them apart, at least so they don't smashed together.
Okay, so we just we tried one of them, and it was it was very simple actually.
Yeah.
So we're not gonna continue with this. It's a bit risky anyhow.
Without the forklift, yeah.
Yeah.
Now we're not gonna do anything more right now. We're gonna prepare for, I mean, obviously we'll need a forklift when we're actually gonna take the lower parts of the keel off. This was just a trial day, make sure that we have all the correct tools, so on.
Yep. Then we'll see if we will try to go for the option of a more conventional keel, or if we keep this one.
That's $1 million question.
Yeah, with this one, if it works, we will be able to go really shallow. But it's also sketchy.
Okay, so we're back working a bit with the battery bank. It's been standing still for a while because we've been waiting for some parts. But now we've gotten everything to finish up the installation of the AC side to be able to make a proper full load test of the system. So what we've ordered is some electrical enclosures or cabinets. This will be the input cabinet, taking the input from shore power and from our generator. Gotten some nice thick 3x6 square millimeter cable to be able to handle all the power that we will have in the system. Yeah, so then that AC side will go into each inverter, and then from each inverter we'll have an output getting combined in this cabinet, which will be our main AC cabinet or whatever you call it, yeah, where all the different loads in the boat will be fused off. Then we have some other stuff as well. There's one small one here for some protection that will be close to the generator. The Multiplus has 2 AC outputs that you can configure so that, for example, one part that we want to have powered all the time, basically what will go to this cabinet, yeah, that will be powered all the time. But then you can also use the second AC output to, for example, at certain conditions, for example when the batteries are fully charged, for example, we can use the potential excessive solar power for heating water or running other appliances that we don't need all the time and so on. But I think this one we will wait with. So today's mission is to basically hook everything up so we can do a proper load test, because before we have just run it with not really a proper installation, just with very thin wires. But now we're gonna do it with the right stuff, so we can try to hit the 10 kilowatts that this is rated for and see if our battery bank can handle it or not. As this installation will run in the 2 multiplexes in parallel, it's very important that both the DC side and the AC side cabling or impedances basically are the same all the way, so that they will be loaded equally. I've cut all the cabling to exact same length, even though the units are installed in a bit different locations. Like here, for example, this is the DC cabling to the unit that is closest to the battery. It will just have to be coiled up in the conducts to make sure that the length are the same, and the same will go for the AC wiring. So I've done some more connections now. Finished up both AC input and AC1 output on both multiplexes. Those cables goes in quite of a mess over here from here comes the input cables, so from the transfer switch goes to both the multiplexes, and AC out both goes together here and get combined into this cabinet where we will distribute our loads. So the idea with this setup is that we're gonna discharge and charge at both maximum discharge rate and maximum charge rate. And then we're basically gonna run the system, measure the temperatures. I think I also will set up an oscilloscope as well, so to see what ripples we have in the system. And basically what we're gonna use as a load is this 9 kilowatt heater that we have hooked up here. I need to put this one in. So now the 2 steps now. We have 6 kilowatts and we have what's supposed to be 9 kilowatts, which is both quite a lot. But let's see how it goes. Oh, you can hear the multiplexes start to hum directly. So now we're drawing 5.7 kilowatts. Quite a lot. So we're drawing 123 amps from the battery now. That's a lot.
Okay, so we've been running the 6 kilowatt version of the heating fan.
Yeah, so now it's up to 9. Everything seems to run fine. We're drawing almost 10 kilowatts out of the battery, and we're supplying 8.5 to the AC loads. Now we're almost at the limit of the continuous power of the two inverters, so that's why they have quite poor efficiency. Almost 200 amps.
And how long have we been running it for now? Maybe
10 minutes maybe?
5-10 minutes?
This is already longer than, I mean, I don't think we can ever even reach these powers in the boat, and we can definitely not run it for that long, because we only have, I mean, it would be this would be like the cooktop running on, really, the cooktop running at full power together with whatever, the oven and the dishwasher at the same time. And that, the heating elements of those appliances will only turn on, and then they will turn off after a while when it's hot. So well, let's see. Yeah, well, let's run it for a while.
But what are the temperature of the batteries right now?
Let's see what the sensor says. We placed the sensors in a bit different locations. So I placed one on top of a bus bar here, one on top of a cell, one over here on the terminal of a cell, and then I put one on the side of a cell as well. So now the highest external temperature is 36 degrees. So 4, that should be. Let's see, that should be this one, I think. I don't remember which one's which one goes where. No, it's probably this one. That's on the bus bar, I guess. The hottest thing is obviously the BMS itself. It's at 73 degrees. It's turned off at 100 degrees of the MOSFET. So we are quite high actually. I mean, we have still a margin of 26 degrees here now. Or this BMS is rated for 200 amp continuous, and that's what we're doing right now. It should be on the limit. You can also see the oscilloscope here. We're measuring the blue line is an AC coupled voltage measurement now, the terminal voltage, the one at multiplus. So it has a peak to peak of 3 volts, which gives us what would that be, an RMS of 1 volt, I guess, roughly. I have seen some figure from Victron, but I don't remember exactly what it was, what they recommend to stay within. And then down here, that's quite, I mean, it kind of makes sense, but it's also that's the current, and obviously that will have a sine wave shape, as the capacitors cannot keep up, I guess, with for each cycle of the sine wave.
So now we started with the battery was 65%. We are now at 32%.
And we've been discharging between 6 and 9 kilowatts, and everything seems fine. I mean, nothing gets. Of course, we get heat build up, but nothing that is. Sorry?
Your arm was super much in the way.
But nothing that's really a problem. I mean, everything. I would say everything seems fine.
And now we should charge it instead. Turn it off and start charging.
Yeah.
And then we should try to charge it to the capacity of our generator.
With the same power, yeah, as the generator.
Great.
Yeah, so let's charge. Okay, then we need to plug in the power to charge from. Now I've set the limit to 29 amps, which is 6.5, drawing 6.5 kilowatts from the grid. Charging with 107 amps, 5.7 kilowatts on the DC side. It's quite a poor efficiency actually. I was expecting a bit better here. It's actually under 90% efficiency.
Now we turn it up even more.
Yeah, so now we have set it to the maximum of what our connection that we have right now can set it to 30 amps. See if we trip the fuse or not.
Okay, so now since both the load test and the charge test we did seemed fine, we are taking everything down in this mock-up so we could put it in the boat sometime in the near future.
I wouldn't say it's not our most prioritized task, but it would be nice to also have it installed in the boat, because then we don't really have a real reliable power source where it is right now. So it would be good to have the batteries to be able to properly work when we are there.
To be continued.